Hello, today we will talking about design consideration for a 5G network architecture. Mobile communications have changed from system capable of transmitting voice conversation for millions of users to a system supporting trillions of devices, primarily transporting data rather than voice. The needs of the data communication are different than that of voice, and current system of 4G long-term evolution networks will be at maximum capacity in the next few years. New technologies and the new network architecture will be required to meet the needs for future users, and there will be many of them. Wireless World Research Forum predicts that there will be over 7 trillion network will be 1,000 times higher than today by 2025. This will drive the need or higher data rates yet reduce energy consumption. These goals cannot be accomplished using the current 4G technology and architecture. Six main challenges are required to be solved in order for 5G to meet expected requirements, and many new technologies and architecture types are believed to be able to accomplish that. Limitation of 4G challenges for 5G. The vast majority of the speed and capacity gains made in the last decade were through improvements in the efficiency of air spectrum use, such as modulation and coding switches, and through spectrum equations. These methods are nearing their limits, so other methods of increase will have to be explored. Current data rates are 1 gigabyte per second for slow or stationary devices, or 100 megabyte per second for mobile devices. 5G seeks out a 10 gigabyte data rate. Again, technology will have to change in order to meet the demand. Base stations account for 70% of cellular operators' electricity usage. Increasing capability would only increase that percentage, which is unstable. 4G is considered to be a descendant of 2G and 3G. Like evolution between aerial generation, 4G took elements of 3G and made them better. Instead of maintaining both circuit switching and internet protocol practice, 4G moved to IP for all services. Advanced radio technologies such as orthogonal frequency division, multiplexing, and multiple input, multiple output arrays were encrypted to make better use of the current spectrum. It's clear that the many small changes made to advance through the various generation will not be enough to make the jump to 5G requirements. Passage from first generation through 2G, 3G, and 4G may have been evolution on the same theme, but many of the techniques that have increased capabilities up to this point are nearing their limits. It seems that a revolution in the mobile communication system must take place. Drastic changes to the entire architecture of cellular networks will have to be made. The main challenge is the standards for 5G have not yet been created, with the future approval expected to occur in 2020. However, telecommunications companies and the international science that last standardization of the International Mobile Telecommunications Advanced Standard in 2008, but specifically for 5G since 2015. Much of the problem creating the need for a new generation of mobile telecommunications comes from a wide explanations of use cases. What once only needed to transmit voice grew to data, and what was once just a handheld devices need is growing into many separate devices, which will be detailed later in this paper. have created or a great number of challenges that the current system cannot support, and simple explanation of the current technologies to do not seem to be solution for the goals of 5G are to support these many new use cases. Connected, connected, connectivity for massive number of devices. Not only are the numbers of devices exploding due to LOT, but the different connections need makes this a wide-ranging challenge. No longer are the needs expected to be smaller. To previous requirements, devices need to be able to range from sleeping until needed to always on, yet get the connectivity when required, handling the massive number of devices that may pop in and out of connection consistently will be a challenge. 4G is not ideal to handle this because current systems are disconnected. According to various short distance communication protocols are not set up to communication with each other. There is no common system. The challenges will be creating a system that is common yet but able to support a myriad number of devices with hundreds of different use cases. Reduce cost and energy storage capabilities are not keeping up with the media abilities of current devices, and the desire to increase those abilities will require a reduction in the amount of energy required in the order to customize with the network. The IoT also is affecting battery for several years. On the provider's side, base station electricity usage and the cost of equipment upgrade to handle the new requirements is a concern that needs to be solved of the business to remain profitable. Current estimates of the percentage of radio network power usage are 70 to 80% of total operation energy usage. This is driving costs higher, and future usage will only increase that. Systems will need to change in order to meet service demand, yet maintain a responsible cost.